Hello and welcome back to Technical Math Virtual Style. Tonight we are going to go ahead and hammer through Chapter 10, which focuses on triangle trigonometry. Now don't let the title scare you at all. I promise you will be fine. We'll go through these notes and you'll feel like a rock star. Okay, the word trigonometry, what it actually means is triangle measurement. So we are really studying triangles. Trigonometry is a branch of mathematics that studies the relationships between side lengths and angles of triangles. In Chapter 8, we covered some of the vocabulary of angles and triangles. So before we dive into this new idea called trigonometry, we need to make sure that we remember those vocabulary words that we covered in Chapter 8. So the first one, you have to make sure that you are comfortable with what an acute angle is. An acute angle is an angle that measures less than 90 degrees. So remember I said it's going to be a small angle. So when I was younger, I always remembered it as like a cute little puppy. You think it's cute because it's little. Well, it's an acute angle because it's little. It's less than 90 degrees. An obtuse angle is greater than or more than 90 degrees. So an obtuse angle is a larger angle. It is more than 90 degrees, okay? A right angle is exactly 90 degrees. And the way that they label a right angle is they put the little box. So this is what an exact 90-degree angle would look like. So an acute angle, the opening would be less than that. So there would be an example. An obtuse angle, the opening would be greater than 90. So there would be an example. A straight angle is 180 degrees. 180 degrees ends up being a straight line. That's why it's called a straight angle, because it's a straight line. So one of the things that our book, and when you get to MyLab, what it's going to have you do is they will give you an angle and they'll be like, yo, is this an acute angle? Is it obtuse? Is it straight or is it right? So today we are going to go ahead and just start off by labeling. The first one, I want you to realize that they did put that little box there. They're telling you by putting that box that this is a right angle. It is exactly 90 degrees. Now, if you look at the opening, this opening is smaller than this. So it's an acute angle. It's less than 90. This opening is wider than our 90 degree. So if it's wider, it's an obtuse angle. Whoa, straight line. If it's a straight line, it is called a straight angle, and it has a measurement of 180 degrees. Now here again, looking at the opening, this is less than this. This is your 90 degrees. You can see that this is open less than that amount, so it is an acute angle. This is wider of an opening when you compare it to the 90-degree angle. So this would be obtuse. Okay, so again, it's kind of nice to start off a new chapter and have some review concepts. And that is one thing that you'll notice tonight as we're going through Chapter 10. They refer to Chapter 8 a lot. So if you like that geometry chapter, it will be to your benefit to kind of remember how everything works. Now, one thing is being able to know how they name angles. Now, all of these, you could actually name them the same way. So if I were to name any of these angles, I could say angle O, because O is located at the vertex. So that is one way. Otherwise, you could do 3 letters, but you have to make sure that you go in order and the vertex is in the middle. So what I mean here is I could say angle A, 0B, O, A, O, B, or I could go the other way and say B, O, A. But the O is the vertex, so it has to be in between the other 2 sides. Okay, so just a little review of something that we did in Chapter 8. Now, typically when we work with angles, we use degree measurements. However, if you're doing some technical work that involves circles, angles are measured or described in an angle unit that is called a radian. So you can actually measure angles using radians or degrees. So by definition, 1 radian is equal to 180 degrees divided by pi, which ends up being approximately 57 degrees. Okay, so they're telling us it's 57.296. So for you visual learners, what happens is if you go ahead and look at this, the 1 radian, that's what A is, that's the measurement, it is about 57 degrees. And again, radians, they relate to when you're looking at what's called a central angle. It's inside of a circle. 1 radian is the angle at the center of a circle that corresponds to an arc. An arc is the outside edge of a circle. Okay, so it corresponds to an arc exactly 1 radius in length. So this is a radius. Remember, the radius goes from the center of the circle to the side. Another concept from chapter 8. This would be a radius measurement. If you flatten this out, it would be the same. And so when the radius measurement ends up being the same as the arc measurement, A, which is the central angle, that's when it's 1 radian. So it's kind of cool. Now, obviously, knowing that you can measure angles 2 different ways, you can measure them in degrees, you can measure them in radians. One of the skills that you really need to be comfortable with is being able to convert from one form to the other. Because what if you are dealing with measurements in degree form and somebody gives you a measurement in radians? Well, you have to be able to convert from radians to degrees. And the other way, if you are looking at a circular object and you have a formula where you need radians and they tell you a degree measurement, you have to be able to make that conversion. So that's what we're going to move into now. If I want to convert from degrees to radians, here is the formula. Okay, so radians equals whatever the degree measurement is times the fraction pi over 180 degrees. When you are using this formula, you use the pi button on your calculator unless they tell you otherwise. So remember, on your scientific calculator, there is a pi key. So that's what they're telling you. When you make these calculations, use that key rather than just typing in 3.14. So let's do some conversions. So here are degrees. If I have a 43 degree angle and I want to convert it to radians, I have to multiply by pi over 180. Now remember, way back in our fraction chapter, we said when you multiply fractions, it's top times top, bottom times bottom. I can always take any value and turn it into a fraction by putting a 1 underneath. So 43 degrees is the same as 43 over 1. Now I can go top times top. So this is 43 pi over 1 times 180 is 180. So I can calculate this. I'm going to put the top in parentheses. It's 43. They said to use the pi key. That is the numerator. Divided by 180. When I hit enter, I have 0.750. So I'll just stop there, 0.75 radians. Okay, let's do another one. If I have a 60 degree angle and I want to convert it to radians, the fraction is pi over 180 degrees. So in order to use our skill multiplying fractions, I turn 60 degrees into a fraction by putting a 1 underneath. Now I can take top times top. 60 degrees times pi is 60 pi over 1 times 180 is 180. Now when I go ahead and calculate this, I'm going 60 pi, I put it in parentheses so my calculator knows, okay, these two things are on the top of the fraction. Fractions mean divide, so the division sign, 180. So this is what it should look like on your calculator. I have 1.047. This is a 1, so I'm going to stop right there. It's not enough to bump that up to an 8. And sometimes, rather than writing out the full word radians, they stop at rad, just R-A-D. Okay, and notice in the directions they did not tell us how to round. So that's why this one I did to the 100th, this one I did to the 1000th. If they tell you how they want you to round, then obviously you'd have to go ahead and follow those directions. But they just said you'll convert. So that's what we did. Okay, but there are times where you might have to go the other way. They might give us radians, and we're like, I don't even know what radians means. I want to convert it to degrees, okay? So here's our formula. You take whatever the radian amount is, and you flip that fraction upside down. Here, it was pi over 180. So now when I'm going the other way, it's the 180 over pi. So I take whatever the radian measurement is, and I multiply it by 180 over pi. So if they tell us, hey, that angle is 1.3 radians, you're like, what does that even mean? Okay. I like to know in degrees what it looks like, so I know if it's acute, obtuse, whatnot. So I would take 1.3, you take the radians, times 180 over pi. So same thing here. I'm multiplying fractions. I go ahead and put a 1 underneath because now I have a fraction times a fraction. Top times top. If I take 1.3 times 180, I get 234 over 1 times pi is pi. So if I calculate this, 234 divided by, they told us to use the pi key. So I just went ahead, 234 divided by pi. It is 74.48 degrees. So now I know that 1.3 radians, it's an acute angle because it's less than 90 degrees. How about 0.05 radians? 0.05, to turn it into degrees, I multiply it by 180 over pi. I'm going to go ahead and take 0.05, turn it into a fraction by placing a 1 underneath. Top times top. 0.05 times 180 is 9. 1 times pi is pi. If I go ahead and divide, 9 divided by pi equals 2.86. The 4 is not enough to bump that to a 7, so 2.86 degrees. Now that's a really small angle. It only opened 2.86 degrees because remember we said an angle, you have your vertex, and what happens is you have two rays. Now what an angle measurement is it tells you how much, this is called the terminal side, how much that side opens up from the original. Okay, so this is only 2.86, so it's definitely also an acute measure. So the skill we were just doing, make sure you know how to convert from degrees to radians and also convert from radians to degrees. Okay, now if you like pizza, this part of the assignment or part of the section is for you. We're talking about sectors. Now sector is a wedge-shaped portion of a circle. It is called a sector. Think of it as pizza, okay? Like it is one piece of pizza. Both its area and its length of the arc, okay? The arc, remember, that's just the outside edge. So for our pizza, that's the crust, okay? The whole thing, the area, that is the entire piece of pizza, okay? It can be expressed most directly if you use radian measure. And the reason why we have to use radians, you guys, is because this is a circle. If you are dealing with triangles, that's when we're really going to focus on the degree measurement. If we are looking at a circle, it's that radian. Now here is your arc length. So to figure out, for my pizza example, to figure out, okay, what is the measurement of the crust? It is R. R is the radius. So from the center of the pizza to the crust, what is that measurement? A. A is the central angle. The central angle means that the vertex of the angle is the center of the circle. And again, it has to be in radians. So if they give us a problem where it's in degrees, we need to be able to convert from degrees to radians, okay? Now, A is the area, okay? So what is the entire amount of space that you have in your piece of pizza? 1/2 times the radius, the center of the circle to the side, like we talked about in chapter 8. You take that and you square it times A. A is the central angle. Again, it must be in radians. So the sector formulas only work when the central angle is measured in radians. So again, if it's in degrees, you have to be able to do these conversions like we did earlier. Here's a couple real-life examples. A sheet metal worker wants to know the arc length. Arc length is the outside edge. And the area. So the area is the entire thing. Okay, of a sector if it has a central angle of 150 degrees and it's cut from a circular sheet of metal and the radius is 16.0 inches. So the first thing I notice is A, my central angle, that is in degrees. So I have to convert it to radians. So I take the degree measurement, 150 degrees. To go into radians, we multiply by pi over 180. I put a 1 underneath the 150. 150 times pi is 150 pi. 1 times 180 is 180. So I go ahead, I have 150 pi on the top, divided by 180. A, the central angle, or sorry, in radians, is 2.6, I'm going to go 2.62 radians. So right there too, I looked and I said 2.6. I'm like, that's an acute angle. It's the whole trying to get your mind to think, are you looking at the degree measurement or are you looking at the radians, okay? So we have 2.62, so that's what we have to use for A. So S, which represents the arc length, is R, the radius from the center to the side. It's 16.0 inches, times the central angle in radians. We just calculated that. I rounded it to the 100th, 2.62. If I take 16.0 times 2.62, S is 41.92. Now the label is going to be whatever the label was for the radius. And in our case, this is inches. So what that means is if I just took this outside edge, okay, the crust, if you will, and I straighten it out and I measure it, it would be 41.92 inches. Now the area, the full space in between, area is 1/2. The radius from the center of the circle to the side, so that's 16.0 squared, times A, which is the angle in radians, 2.62. I can go ahead and enter this all at one time. 1/2 is 0.5 times 16.0, we square that, times radians, 2.62. The area is 335.36. Remember, area is always squared. Our label is inches, so this would be inches squared. Or you could put squared inches. We're doing one more just to make sure we've got it, okay? If you are looking at a sector, here are your two formulas. S is the arc length, so think of the crust of a pizza. Area is the entire piece of pizza. A has to be the measurement inside, the central angle, but it has to be in radians. So the first thing that I notice again is the little buggers gave us this measurement. They gave it to us in degrees. So I have to first convert it into radians. 80 degrees times, the formula is pi over 180. If I put a 1 under 80, top times top, 80 times pi is 80 pi. Over 1 times 180 is 180. So here are my radians. I'm on the top, 80 pi divided by 180. I have, 1.396. So if I want to follow what I've been doing and round to the 100th, the 1,000th, if I go 3 values over, this is bigger than a 5. So it would bump the 9 to a 10, which would bump this to a 4. So I'm going to say it's 1.4 radians. Now I can go ahead and find the arc length. So S is the radius from the center of the circle to the side. They tell us it's 25.0 feet. You multiply it by A. A is the angle measure in radians, so it's 1.4. 25.0 times 1.4 is 35. The measurement is going to be the same as whatever the radius is, so it's going to be 35 feet. So again, what that means is if I go ahead and I cut this off and I straighten it and measure it, it's going to be 35 feet long. Your area, it's 1/2, whatever the radius is, 25.0 squared times A. A is the angle measure in radians, 1.4. I can go ahead and put that in at one time. If I go 0.5, 25.0, square that value, times our radians, which was 1.4. I have 437.5. Area is squared. Our measurements are in feet, so it's squared feet, or you can also write it as feet squared. Okay, now this is some fun stuff. If you ever take a trigonometry class, maybe you did in high school, or maybe you will go on and take one just for fun someday. Linear and angular speed are kind of cool. In an actual trig class, sometimes what you can do is calculate things like how many times does your sock rotate around in the washing machine when it's on spin cycle. Okay, that is something that is so funny. Or like, what is the actual speed of a Ferris wheel? Those types of things. Excuse me. So now we're going to go ahead and talk about some of these other ideas that pertain to trigonometry. Linear and angular speed. They are two totally different things. Okay, radian units are used when you're doing the rotation of an object, because remember, the rotation means that you're going in a circular motion. If you're talking about circles, your measurements are radians. Okay, when an object moves along a straight line for a certain distance, they're calling it d, that's what d stands for, distance, in whatever time, so seconds, minutes, hours, years, its average, it's called linear speed, because you're traveling in a straight line. So a linear speed, it is v equals whatever the distance was divided by the time. Here's an example. If a car travels 1,800 feet in 24 seconds, what is its average linear speed? So linear speed, they gave it the variable v. D is the distance. How far did you travel? 1,800 feet over t is the time. You traveled that in 24 seconds. So v, your linear speed, now you just divide. 1,800 divided by 24 is 75. Your label, you're going 75 feet every second. That is linear speed. Now, when an object is going around in a circle, like when your sock is traveling inside of the washing machine, when it's on spin cycle, okay, that's angular speed. If you're looking at like the carts on the outside of a Ferris wheel, that's angular speed. So when an object moves along a circular arc, the distance s in time t goes through an angle A, again, it must be in radians, and its average angular speed can be found, they call it W, is found with this formula. So the angular speed is A, it's the angle in radians, over T. T is how long it takes. This formula will not work unless A is in radians again. So here's an example. If a 24-inch diameter flywheel rotates through an angle of 140 degrees in a time of 1.1 seconds, what is the average angular speed? So we need the angle, but again, because we're talking about a circle, they gave us degrees. We have to turn that into radians. So A is 140 degrees times pi over 180. I put a 1 underneath, top times top, 140 pi over 1 times 180 is 180. So if I calculate this, 140 pi divided by 180, I have 2.44 radians. Now I can do this. Our angular speed, which is W, is whatever your angle is, make sure it's in radians. So for us, it was 2.44 radians over time. Time was 1.1 seconds. So if I divide this, if I go 2.44 divided by 1.1, your angular speed is 2.2. If I round it to the 100th, this 8 is enough to bring that 1 to a 2. So it'd be 2.22 radians per second. So every second, you are traveling 2.22 radians, okay? Real life examples. If a bicycle travels 24 miles in 1.5 hours, find its average linear speed. So we're talking about how much the bicycle actually traveled versus, we could be all tricky and just talk about how much the tire rotated, then it'd be angular speed. But we're saying the bicycle traveled a distance, a linear distance of 24 miles in 1.5 hours, find its linear speed. So linear speed is V, distance, 24 miles over time, 1.5 hours. So if I take 24 and I divide it by 1.5, it is 16. The label is miles per hour. So that's how fast that person was riding their bike. Kind of cool. A Ferris wheel at an amusement park takes an average of 40 seconds for one non-stop revolution. Now a revolution, okay, if you picture a circle, and hopefully this is something that you remembered, if not, we got it right now. One full circle equals 360 degrees. So when they talk about a revolution, every revolution is equivalent to 360 degrees. Okay, so again, we have the Ferris wheel. It takes a time of 40 seconds to make one revolution. So A, the angle, but again, guys, they gave us 360 degrees. We need A to be in radians. So I multiply by pi over 180. Go ahead and turn the 360 into a fraction by putting a 1 underneath it. The top is 360 pi. 1 times 180 is 180. If I go ahead and calculate this, 360 pi divided by 180 is 6.28 radians. Now I can go ahead and calculate the angular speed. It is W equals the angle in radians, 6.28 radians over the time. It takes 40 seconds to make that one revolution. So you divide the numbers. 6.28 divided by 40 is 0.157, so I'm going to go 0.16 radians every second. So that is linear and angular speed. Let's keep on going. Okay, back to some Chapter 8 review stuff. Before we jump right into the trigonometry, which I got, guys, it's coming, like the sine, cosine, tangent stuff, okay? You have to understand what a right triangle is. So recall from Chapter 8, if something is a right triangle, it has to have a right angle. And a right angle means that it's exactly 90 degrees. So all of these are examples of right triangles because this has a right angle. This has a right angle. This has a right angle. And again, notice they always mark that off for you just so you know where the 90-degree angle is. Trigonometry is basically triangle measurements. And to keep it simple as possible, we are going to study right triangles. So things that we look at when we're talking about a right triangle. The two sides that form the 90-degree angle. Okay, so the two sides that actually touch that right angle, they are called legs. The side that is across from the 90-degree angle, that is called the hypotenuse. The hypotenuse is always the longest side of the right triangle. So if we're looking at measurements, your hypotenuse needs to be the longest side. Also covered in Chapter 8. I like all the review stuff, you guys. Also covered in Chapter 8, we looked at the Pythagorean theorem. The Pythagorean theorem is an equation, and what it does is it relates the lengths of the sides of any right triangle. And this formula is true for every right triangle. It doesn't work on scalene triangles and all of those other things. You have to have a right triangle, okay? Here is the formula. A squared plus B squared equals C squared. Or you could have C squared equals A squared plus B squared. The main thing that you know is that A and B are the legs. So you take the two sides that touch the 90-degree angle, you square them, add them together. That value is on one side of the equation. C, your hypotenuse, the side that's across from the 90-degree angle, you square that, and that's on the other side. And from there, we can find missing sides, okay? So let's go ahead and use the Pythagorean theorem. This is a leg, this is a leg. What I'm missing is the hypotenuse, which in the Pythagorean theorem is C. Your legs, it doesn't matter which one is A or B, because what you're doing is squaring them and adding them together to create one value. So I'm going to say this is A and this is B. If you jumped ahead of me and had this is A and this is B, totally fine. So A squared plus B squared equals C squared. Now I can, if you're careful, you can put this in your calculator one time. 20 squared plus 21 squared. This side is 841 equals C squared. We want to know what C is. So remember, the opposite operation of a square is a square root. So what I need to do here is take the square root of each side, because a square root cancels a square, so C is alone. So my answer is whatever the square root, and on your calculator, notice on mine it's right above x squared. There's the square root symbol. So in order to get that, I have to hit the second key. So second x squared, I think I hit it twice. Second x squared, so there's the square root of 841. It is 29. So this measurement is 29 inches. And notice this is the hypotenuse it is longer than the two legs. One more like this. This is a leg and this is a leg. This is the hypotenuse. The hypotenuse has to be C. Let's say this is A and this is B. So what I'm trying to find here is B. A, 6.5 squared, plus B, we don't know B, equals C, 18.1 squared. So I'm going to go ahead and do the exponents. 6.5 squared, this is 42.25 plus B squared equals 18.1 squared, 327.61. Now, if I want to solve for B on the same side of the equation as B but not touching is your 42.25. So I need to go ahead and minus that to the other side. So B squared equals, take 327.61 minus 42.25. It's 285.36. Now to solve for B, I need to cancel the power of 2. In order to cancel a square, you do the inverse operation, which is take the square root. Square cancels a square root. B is by itself. My solution is the square root of 285.36, which is 16.89 if I round it to the hundredth. And the label here were centimeters, so that label will carry on over. And again, this is the hypotenuse. If I look, once I found this missing measurement, this is 16.89. Your hypotenuse is the longest of the three sides. Okay, so here we go. Let's move into triangle trigonometry. You will be seeing that there are some fixed ratios, and this works in all right triangles. The first skill that you have to be able to do, though, is be able to identify the sides of a right triangle. One side is called the opposite. One is the hypotenuse, which we just talked about within the Pythagorean theorem, and the other side is adjacent. So the first thing you have to know is what angle are you focused on? So here, like let's say I am doing angle B. To find the opposite, you draw an arrow from the side that you're focused on. So this would be the opposite of angle B. Hypotenuse is always across from the 90-degree angle. The adjacent is the third side. So that is an important skill. So that's what we're going to go ahead and do right now. Notice this is I, G, H. This is also I, G, and H. When you are looking at triangles and they're labeled, the angles are always labeled with capital letters and the sides are always lowercase. Okay. The hypotenuse, your hypotenuse is located across from the 90-degree angle. So if I draw an arrow from the 90-degree angle, it points to the hypotenuse, so that would be G. The opposite side of angle H, so that means I'm focused on H. To find the opposite, you draw an arrow from that angle, so the opposite is H. The adjacent, so from H, this is the opposite. This is the hypotenuse. The adjacent is the third side, so it would be I. Now they're switching and saying, all right, well, what if we're focused on I? So here's I. Across from I, the opposite is lowercase I. Across from the right triangle, or the right angle, that's always the hypotenuse, so your adjacent would be H. So notice that it does change. Like here, when we were looking at angle H, the opposite was H. But when we were looking at angle I, the opposite was I. So it's important to know which angle you are focused on, because in order to find the opposite, you have to draw an arrow from that angle. And whatever it points to, that's the opposite. If you draw an arrow from the 90-degree angle, it will always point to the hypotenuse. The third side is called the adjacent side. The terms adjacent, opposite, and hypotenuse, they are only used with right triangles. They do not apply to other triangles. Every right triangle has 6 fixed ratio relationships that connect the size of either of the acute angles in that right triangle to the lengths of the adjacent side, the opposite side, and the hypotenuse. These 6 ratios are called the sine, cosine, tangent, secant, cosecant, and cotangent. So there are 6. In this course, we just study sine, cosine, and tangent. Okay, they are the basic 3. To help you remember these ratios, there is a phrase. It's SOHCAHTOA. Okay, it sounds kind of silly. I'm going to teach you my chemistry teacher's old trick in a minute here too. So this is SOHCAHTOA. the way that it helps you, the sine of theta, and theta is any angle. So whatever angle from the triangle you're focused on, that will be placed right here. So the sine is the opposite over the hypotenuse. That's how they get SOH. Sine, opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and that's what this is. Cosine, adjacent over hypotenuse. Tangent is the opposite over the adjacent. Okay, so SOHCAHTOA, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay. Like I said, the chemistry teacher here at one point, I laughed so hard. I always did the whole SOHCAHTOA thing. Like if you stub your toe, you want to SOHCAHTOA in water to make it feel better. Well, the chemistry teacher said, some old hippie caught another hippie tripping on acid. And for some reason, I laughed and laughed, and it was something that I never forgot. So whichever way it helps you to remember your sine, cosine, and tangent, definitely use that. It's pretty funny. Okay, so let's go ahead, and here is a right triangle. So if I want to find the sine of 50, what that means is that we are focused on the angle 50. So from 50, if I draw an arrow, this is the opposite. This is across from the 90, so that's the hypotenuse. The third side is the adjacent. If I want to find the sine of 50, the sine of 50, sine is opposite. The side that I labeled opposite is 47.5 over the hypotenuse is 62.0. This is all you're calculating. You're calculating the ratio, which is a fancy way of saying a fraction. They want us to round it to 3 decimal places. So 47.5 divided by 62.0, if I round it to 3 decimal places, it's 0.766. 0.766. Done. Okay. Now if you want the tangent of 40, so here's 40. Across from 40, that is the opposite. Across from 90, that is the hypotenuse. So now, when I'm looking at 40, the adjacent is 47.5. So if I am looking at the tangent of 40, I'm just making the ratio. I'm just making the fraction. Tangent is opposite over adjacent. The opposite of 40 is 39.9 over the adjacent from 40. The adjacent is 47.5. So we're rounding it to 3 places. All you're doing is calculating this fraction. 39.9 divided by 47.5. If I round it to, it says round to 3. So they gave us 0.84. If I'm rounding to 3 places, you just plop a 0 on the end. Now you have 3 values. Okay, let's do the cosine of 50. All right, well, 50 I already have labeled here in the gray. This is the opposite. This is the adjacent. This is the hypotenuse. So if I want the cosine of 50, cosine is adjacent. It's 39.9. That's the measurement of the adjacent side over the hypotenuse, which is 62.0. This time they want us to round to 2 decimal places. So I go 39.9 divided by 62.0 and round it to 2 places. So 0.64, if I look at the third value, it's not enough to bump that up. So it stays at 0.64. So SOHCAHTOA, or some old hippie caught another hippie tripping on acid. That helps you to figure out or remember that the sine is the opposite side divided by the hypotenuse. The cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Okay, now one skill that we definitely want to cover in this class is how to use scientific calculators. Scientific calculators are set up to calculate the sine, cosine, and tangent in both radians and degrees. In this course, we just practice how to do this in degree measurement. So before we go to the next part, you want to make sure that your calculator is in what's called degree mode. So right next to the second key, you'll see where it's DRG. It's degrees, radians, okay, and that's what the D and the R are. It's talking about our trigonometry. We want our calculators in degree mode when we're doing this. So that's all you do here. Let's say if it was in radians, you just go ahead and switch it. So once it's on DEG for degree, you go ahead and hit enter. It says use a scientific calculator to find each of the following. Okay, let's go ahead and we'll round to 2 places. okay, because it doesn't tell us. Your calculator, you'll notice, has sine, cosine, and tangent keys. That's all you have to do here. So if I want the cosine of 26, I hit cosine. Cosine of what? 26. Notice it opens a parenthesis. What do you want the cosine of? Once you've entered everything, close the parentheses. So this is what the cosine of 26, we know it's in degree mode because if I go ahead and I see that it's underlined under degree, that means that it automatically put the degree symbol with the 26. Hit enter. If it's 0.898, that would bump it up to 0.90. Okay, let's look at B, tangent of 67.8. So I hit the tangent button. The tangent of what? 67.8, close it. We already have it in degree mode. If I round it to 2 places, it is 2.45. This is just putting things in the calculator. Yes, you do have some of these in my lab for the quiz and the homework. So again, just make sure you have that scientific calculator. Make sure it's in degree mode. If I'm rounding to 2 places, 0.669, that 9 is going to bump it up. So I have 0.67. 47 and 1/2. And it's a cosine. So cosine 47, 1/2 is 0.5. So 47 and 1/2 is 47.5. If I round it, I have 0. If I'm rounding to 2 places, I look at the third. This is a 5, so it bumps that up. So it's 0.68. Cosine of 151.6. Cosine 151.6, close it. I have negative, check that out, negative 0.879. The 9 would bump that up, so negative 0.88. And last but not least, this is a sine function, so you hit the sine button to start. 39.46, we are in degree mode, so go ahead and hit enter. It said to round it to 2 places, so 0.635. The 5 would bump that to a 4, so 0.64. So that is just a skill that we want to make sure that you understand is you can actually calculate trig functions using a calculator. Just make sure it's in the degree mode first. Okay, next part. You can solve for variables in a trig equation. Remember, solving means to get the letter by itself. So if I have something like these 3 equations right here, and this is where we'll be practicing this skill. If I want to know what A is, I need to cancel a cosine. Or here, if I want to know what A is here, I have to cancel the sine. Here, I'd have to cancel the tangent. The inverse operation of the sine, cosine, and tangent are the inverse sine, the inverse cosine, and the inverse tangent. So the inverse, they look like this. It's the trig function, and it looks like it has an exponent of a -1. That's how you cancel a trig function. And again, it's on your calculator. If I look above the sine, you'll see that there's the inverse sine. If I look above the cosine, there's the inverse cosine. If I look above the tangent, there's the inverse tangent. In order to get these yellow options, you just hit the second key before you hit the button that you want. So let's go ahead and solve. Use your calculator to solve for A. So if I want to get rid of a cosine, what I'm doing is I'm taking the inverse cosine. What you do to one side of an equation, you do to the other. An inverse cosine cancels a cosine, so A is alone. Now on this side, I want the inverse cosine, so second cosine. I want the inverse cosine of 0.589. It says rounded to the nearest 1/10 of a degree. So 53.9, and they're telling us it's a degree. So 53.9 degrees. If I want to solve for A, right now it's the sine of A. I need the inverse sine. What you do to one side of an equation, you do to the other. An inverse sine cancels a sine, so A is alone. Now at this point, it's just your calculator. Second sine, so I have that inverse sine, 0.248. The directions say to round it to the nearest 1/10. And so I'd have 14.35. The 5 would bump that to a 4. They told us it's in degrees, so 14.4 degrees. Last one. If I am solving this equation, I need to cancel a tangent. In order to cancel a tangent, you use the inverse tangent. Inverse tangent cancels tangent, A is alone. To do this on your calculator, inverse tangent of 1.75, rounded to the 1/10. So I look at the 100th place. This is a 5, so it would bump the 2 to a 3. 60.3 degrees. So it's really cool. You guys, you can solve equations now by canceling trig functions. The last skill for chapter 10, we are reaching the end. Awesome. The last skill is to be able to put all this information together. The fact that every interior angle of a triangle has to add up to 180. That's something we talked about in chapter 8. That is important here. The Pythagorean theorem, which we did in chapter 8 and again today. That is important. Being able to use sine, cosine, and tangent to find missing measurements. That is important because when you are solving a triangle, you're not done until you know every measurement inside and every measurement outside. So let's go ahead and do this. It says what we're going to do for rounding. For the sides, we are going to round to 2 decimal places. For the angles, we're going to round to the nearest whole degree. So if I am trying to solve this triangle, the first thing that I try to do is figure out the interior measurements, okay? Every single triangle always has to add up to 180. So right now, I do not know the measurement of angle B. The measurement of angle A is 28 degrees. C, remember if it has that little box, that means this is 90 degrees. So if I want to find B, I just take 180, the total from every triangle, minus the 2 that we already know. So if I take 180 minus 28 minus 90, the measure of angle B is 62 degrees. So this is 62. So right now we know all of the inside measurements. Now I need to know all of the outside measurements. I only know side C. I only know the hypotenuse. So let's go ahead and use trig. Let's say I try to find A. If I want to find A, I'm going to go ahead and go from 28. So this would be the opposite. This would be the hypotenuse. This would be the adjacent. So I need a trig function that has the opposite because I want to solve for A. The other value that I know is the hypotenuse. So remember, if I have my SOHCAHTOA, I'm finding the opposite using the hypotenuse, so it's the sine. So the sine of A, which is 28, the sine is the opposite over the hypotenuse. If I'm trying to solve for A, this is A divided by 9.6. In order to undo division, you multiply both sides by 9.6. This cancels this. A equals 9.6 times the sine of 28. We said that we are rounding the sides to 2 places, so 0.506, the 6 would bump the 0 to a 1, so this would be 4.51 meters. So that's what A is, 4.51. Now, if you know 2 sides of a right triangle and you just need the third one, the Pythagorean theorem is probably the fastest way to do this. Here's A, we don't know B, the hypotenuse is always C. So A, 4.51 squared, plus B, we don't know squared, equals C, 9.6 squared. So 4.51 squared is 20.3401 plus our surprise side, we don't know it yet, B squared, equals 9.6 squared, which is 92.16. Now I'm solving an equation. So you see where so much of the stuff that we have done together this semester, it's all kind of coming together. Like now we are solving for a variable. We practice solving during our algebra chapter. Whatever's on the same side of the equation as B needs to go to the other side. So I need to minus 20.3401. And during chapter 7, we said what you do to one side of an equation, you always do to the other. So we're seeing those skills over and over and over. That's just kind of how math works. Once you learn something, it just kind of hangs around. This is 71.8199. To cancel a power of 2, you have to do the square root. A square root cancels a square. So B is the square root of 71.8199. This is a side, so we are going ahead and rounding it to 2 places. So this would be 8.47 meters. So when I go ahead and 8.47, this triangle is said to be solved. It is solved because I know all 3 measurements on the inside, I know all 3 measurements on the outside. And in order to do this, we had to know three totally different things. We had to remember that every triangle adds up to 180 degrees. We had to know how to use sine, cosine, and tangent. We had to know how to use the Pythagorean theorem. So you guys, it's a lot of information. None of it is new at this point. It's just showing you how it's all tied together. Okay, one more example. This is 90. Now I can't do the same process that I just did in the other triangle because I'm missing two interior angle measurements, okay? But I like to go ahead as soon as I see that I have two of something, whether it be two sides or two angles, to try to find the third. Here's my 90-degree angle. So this is a leg. This is a leg. Your legs are A and B. This is C. So I can go ahead and find this missing side right away. Pythagorean theorem. A, 4.27 squared, plus B, we don't know, so B squared equals C, 6.84 squared. I go ahead and do the math. 4.27 squared is 18.2329 plus B is our variable. You can't calculate B squared in the calculator because we don't have a numerical value. 6.84 squared is 46.7856. To solve for B, I need to get rid of 18.2329. What you do to one side of an equation, you always do to the other. I'm going to go ahead and subtract that, 2329. This ends up being 28.5527. To cancel a power of 2, you take the square root. So B is whatever the square root of 28.5527 is. B is a side. We are rounding the sides to two places, so it's 5.34. And again, they labeled this meters, so 5.34 meters. Now I know all three sides, but I only know one angle. You're not done until you know all three angles. So let's say I try to find B. I have to use trigonometry here. So I can pick, you guys, you have a choice here. You could use sine, cosine, or tangent. Okay, I'm going to go ahead and do the sine. So the sine of B, sine is opposite. Opposite across from B is 5.34 over hypotenuse. Across from the 90 is 6.84. So if I calculate this, the sine of B equals 5.34 divided by 6.84. It is 0.78070. Okay. Now if I want to find B, and they told us that our angles are rounding to the nearest whole number, I need to cancel a sign. In order to cancel a sign, you do the inverse sign. What you do to one side, you always do to the other. This cancels this. B equals the inverse sine of 0.7807 rounded to the nearest whole number. 51.3 would be 51 degrees. So B is 51 degrees. Now to find this measurement, I can go ahead and say, okay, 180, because it's a triangle, minus this 90, minus this 51, and that will go ahead and give me the missing angle measurement, which in this case is 39. So again, notice that when you're solving a triangle, you're doing three different things. You have to know that every triangle adds up to 180. You have to be comfortable with your trig functions because you will need to use either sine, cosine, or tangent, and you have to know the Pythagorean theorem. So there's three things that you need to understand in order to solve a triangle. Last two questions. I'm trying to keep this under an hour, and I think we're going to do it, guys. Okay, so why in real life do we have to do this? Here's just a couple examples to show you that you may actually use this in real life. Hopefully you do, okay? The most efficient operating angle for a certain conveyor belt is 31 degrees. If the parts must be moved a vertical distance of 16 feet, what length of the conveyor is needed? So what they're telling you is if you want it efficient, this needs to be 31 degrees. You are trying to move something a vertical distance of 16 feet. They want to know what length, trying to find this. What length of conveyor belt do you need? So we have to use trigonometry here. I can't use the Pythagorean theorem because I don't know two sides. I know an angle on one side. So I know the opposite. I'm looking for the hypotenuse. The trig function that is opposite and hypotenuse is the sine. The sine of the angle, and we know the angle is 31. So the sine equals the opposite, 16, over the hypotenuse, which is L. So here's my equation. Now we're back to equations. I want to solve for L. This is 16 divided by L. So if I multiply both sides by L, I cancel the fraction. So this is L times the sine of 31 equals 16. Well, this is multiplication. In order to undo multiplication, because I want L by itself, I need to divide both sides by the sine of 31. So L, which is the length of the conveyor belt, is 16 divided by the sine of 31. Let's go ahead and do that. 16 divided by the sine of 31. So your conveyor belt, it doesn't tell us how to round it, so let's go ahead and do by the 10th again. So by the 100th, 31.07. The label will be in feet because when they talked about distance that they were trying to travel, that was in feet and that label will just stay. Okay, so using trigonometry, knowing that you had an angle, you knew the opposite, you were looking at the hypotenuse. The trig function that is opposite in hypotenuse is the sine. Here's one more example, and we finished another chapter, guys. A 20-foot ladder leans against a building. So here's your ladder. Draw your little ladder because it's kind of fun. Okay, this is a 20-foot ladder. It leans against a building, so check this out. When a ladder leans against a building, what you just formed is a right triangle. Okay, a 20-foot ladder leans against a building with a 65-degree angle with the ground. So this is 65 degrees. Draw a diagram. Okay, we already did that. Will this reach a window that is 17 feet? So what we want to know is how high will that go? So across from the 65, that is the opposite. Across from the 90, that is the hypotenuse. So I'm using the hypotenuse to solve for the opposite. So again, opposite and hypotenuse is the sine. The sine of the angle, which is 65, equals opposite over hypotenuse. If I want to solve for x, on the same side of the equation as x is our denominator. This is x divided by 20. So to undo division, you multiply. Check this out. X is all by itself. That's what we want. We want to solve. So take 20 times the sine of 65. 20 times the sine of 65. That, the height, if this is the scenario, if this is 20 feet and this is a 65-degree angle, x, the top of the ladder, is going to hit 18.13 feet. The question says, will it reach a 17-foot window? Why, yes, it will, because it will actually reach up to 18.13 feet. You guys, that was chapter 10. I hope you enjoyed our lecture via YouTube video. By Thursday at midnight, please make sure that you complete your MyLab chapter review homework and the quiz. I hope you guys are having an awesome week. I'll talk to you soon. Bye.